So when we think about finding life out there, we usually focus on the planet, right? The right star, the right orbit. But what if we're thinking too small? What if the real secret is finding the right neighborhood in the whole galaxy? I mean, think about it. When you're house hunting, you don't just look at the building. You check out the neighborhood, right? The schools, the vibe. Well, scientists are now doing the exact same thing for the cosmos. They're asking, are some galactic neighborhoods just better for life than others? It's this awesome idea of cosmic real estate. Okay, so before we can go galaxy-wide, we have to start with the concept that kicked this whole thing off. And you've probably heard of it, the Goldilocks zone around a single star. So this kind of breaks down what makes a planet just right. First off, you need a calm, stable star, not one that's constantly throwing cosmic tantrums. You also want a nice, nearly circular orbit so you don't get these insane temperature swings. And then, of course, there's the big one. It can't be too hot, can't be too cold. It has to be just right for liquid water, the main ingredient for life as we know it, to exist. And that's really the heart of the habitable zone. It's a simple but really powerful idea. It's that perfect sweet spot around a star where a planet could have liquid water on its surface. For decades, this has been our main map for where to look. But as we're finding out, it's just the first piece of a much, much bigger puzzle. All right, so let's zoom out, way out. We're moving beyond a single solar system and looking at the whole Milky Way. And scientists are applying that exact same just right logic to our entire galaxy. Are there good neighborhoods and bad neighborhoods for life on a galactic scale? And look, this isn't just some fun thought experiment. It's actually super practical. As astronomer Jesper Nielsen says, figuring out the galaxy's prime real estate can help us better understand where to point our telescopes. I mean, it makes perfect sense, right? It helps us focus the search, telling us where to aim our best telescopes to have the best shot at finding, well, anything. Okay, but before we can go searching for the best neighborhoods, we kind of need a map of the city, right? So let's do a quick tour of the main parts of our home galaxy, the Milky Way. Think of it this way. Right at the center, you've got the bulge. It's like a dense, old-school downtown packed with the galaxy's oldest stars. Then there's the thin disk. That's where we live. It's the bustling main city, with all the spiral arms acting like suburbs. Now, wrapped around that is the thick disk, which is like an older, more spread-out layer of stars. And finally, surrounding the whole shebang is the halo, this huge, hazy sphere of gas, dark matter, and a few stray stars. So, with that map in mind, scientists took their first shot at defining a galactic habitable zone. And the shape they came up with? It was a donut. Seriously. This idea really kicked off back in 2004. A team of Australian scientists decided to model the entire history of the Milky Way to figure out, okay, where in this giant galaxy would life have the best chance to get started and survive? Their whole model was built on three key ideas. First, you need stars that have enough heavy elements, the raw materials to actually build rocky planets like Earth. Second, those stars need to be old enough so that complex life has time to evolve. And third, you gotta be in a safe neighborhood, somewhere you're not getting constantly blasted by nearby supernova explosions. And here's what they came up with. The ultimate sweet spot, this galactic habitable zone, was a donut-shaped ring. If you get too close to the center, you get fried by all those supernovae. But if you're too far out, there just aren't enough heavy elements to build planets in the first place. And guess what? Our solar system sits right inside this proposed zone. Pretty neat, huh? But you know how science works. It never stands still. In the years since that first theory, we've gotten a ton of new data and run way more powerful simulations. And it's giving us a much sharper picture. The best way to think about it now, it's the cosmic city versus the cosmic suburbs. So let's really compare these two main residential areas of our galaxy. You've got the thin disk, that's our bustling young city. It's crowded and it is loaded with heavy elements, all the ingredients you need for planets. Then you have the thick disk. Think of it as the quiet, older suburbs. It's way more spread out and its stars are kinda element poor. They just don't have as much of that crucial planet building stuff. And the latest simulations really spell this out for us. This chart shows just how many super-Earths, which are one of the most common types of planets we've found, are in each disk. And the difference is just, wow, it's not even close. According to the research, these planets are way, way more common in the resource-rich, thin disk. And this isn't just a computer model telling us this. We have real-world observations to back it up, thanks to NASA's incredible Kepler Space Telescope. The data it collected found that yes, stars in the thin disk, our neighborhood, really do have more planets than the stars in the thick disk. So the evidence is piling up that this is the place to be if you want to form planets. This quote from Jessie Christensen at Caltech just nails it. She says that even inside the busy thin disk, you've got your urban areas and your quieter suburbs, and planets might actually do better in these less crowded, more open spaces. And here's the real kicker. Our own sun, we're in one of those sparsely populated suburban zones. We're galactic suburbanites. So all of this, all the research, the simulations, the data, this whole cosmic geography lesson, it's all leading us to one of the biggest, most profound questions we could possibly ask. And we are right on the edge of getting even better answers. We've got future missions like the amazing Nancy Grace Roman Space Telescope that are going to survey the galaxy with such incredible detail that we'll start to understand planet formation the same way a demographer understands human populations. We're talking about a true census of worlds. And that brings us right back to the ultimate question, which astronomer Vedant Chandra put so perfectly. Was life here on Earth inevitable? Was it special? Was it just a natural result of being in the right place with the right stuff? Or was it some kind of incredible fluke? By finally understanding our place in the cosmic neighborhood, we are getting closer and closer to finding out.